give you a brief introduction to QCI, Quality Council of India. Quality Council of India was established as an autonomous body under the Ministry of Commerce and Industry with the vision of creating an ecosystem for quality. QCI is led by the dynamic leadership of our chairman, Mr. Adil Zainul Bhai, and Secretary General, Dr. Ravi P. Singh. As an apex quality organization, QCI has 5 constitutional boards. National Accreditation Board for Certification Bodies, NABCB, National Accreditation Board for Education and Training, NABET, National Accreditation Board for Hospital and Healthcare Providers, NABH, National Accreditation Board for Training and Calibration Laboratory, NABL, and National Board for Quality Promotion, NBQP. This webinar is also brought to you by NBQ. QCI also has special project divisions, including Project Planning and Implementation Division, PPID, Project Analysis and Documentation Division, PADD, Zero Defect and Zero Effect Division, Z, and Training and Capacity Building Cell, TCB Cell. With all its constituent boards and divisions, QCI continuously leads its mission of a national-wide quality movement. Our today's webinar is another bid for the vision of QCI. It is about the VDA, FMEA, Failure Modes and Effect Analysis. Failure Modes and Effect Analysis, FMEA, is a systematic, proactive method for evaluating a process to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts of the process that are most in need of change. This webinar aims to understand the difference between the existing FMEA and the VDA FMEA, the methodology of the VDA FMEA, and various FMEA methodologies in brief and their advantages and disadvantages. With this, I welcome today's speaker, Mr. Sridhar Gurur, a mechanical engineer and a qualified Six Sigma Master Black Belt with 35+ years of value-added industrial experience in manufacturing, quality, and design in aerospace, heavy engineering, automotive, engineering services, and medical domains. His major achievements include filing of 6 patents and authoring many articles on quality to various international quality portals and journals. He has mentored more than 300 Six Sigma and Kaizen projects and is a qualified internal auditor for ISO 9000, IATF 16949, and AS 9100, the other quality systems. He is also associated with the implementation and sustenance of CMMI L5 activities. He is contributing EHS and community development programs as a CSR activity. I'm certain that you all will be beneficial from his knowledge. But before we move on to the webinar, I would like to announce that all the questions will be considered at the end of the session. You may type the question in the chat box, and these will be discussed during the Q&A session. And the link of this webinar, the YouTube link of this webinar will be shared with you all. With this, I welcome Mr. Gurur. Over to you, sir.
Thank you, Himali and Pooja. Let me share my presentation. I'll just switch off my cam to save on the bandwidth. Is it visible?
Yes. Yes, sir. Your screen is visible.
Okay. Yeah, good morning all. Can we start?
Yes.
Okay. Good morning all. Welcome to the session on AAG VDA FMEA. I think I'm sure that all of you would be using FMEA because it is, as I told, it is a risk management tool and a preventive action tool. So if you are doing design, you would be using FMEA. You have to use FMEA. That is DFME. And if you are manufacturing anything, any process related, you have to use PFME. That is by default. In addition to that, there are other types of FMEAs which we will go through as we go along the presentation. And today we will be talking about the new VDA FME. So before I start, let me introduce myself. It's already been told by Himali. I'm also a mechanical engineer, like I think most of you. I worked for more than 35 years in various companies. Worked in BEML, Mysore, Autoliv, Bangalore, GE Medical Systems, Bangalore, Satyam, L&T, Moog Aerospace, Bangalore, all Bangalore. I'm associated with many of the professional bodies as a trainer, jury member, etc. in various capacities. I've done a lot of value engineering projects and failure analysis projects. I received this recognition last month in February. So I'm just happy to share it with you. So Gurur Consultancy is my own consultancy, which I am doing it since past almost 7 to 8 years. So I'm into quality consulting and training for various types of industries. I filed 6 patents, all from GE, 1 from L&T. It's all approved. Then I'm a qualified 6 Sigma auditor, black belt, and other things. And what we are doing is also equally contributing to EHS and community development program as a CSR activity. In the sense that we have adopted this school in our village, that is Gorur, around 180 kilometers from Bangalore. It's about 100 years old government building, government school. So we are giving them infrastructure, we're funding them for building toilets for girls. Then we are giving them tables, chairs, almirahs, whatever they want, we are giving them. We are giving them interest-free loans. We are giving scholarships to the students. We are doing that since past 20 to 30 years in my grandfather's name, because he was part of the school. He was associated with my father, studied here. And you know, Captain Gopinath, the founder of Air Deccan, he is our neighbor in the Gurur, same village. He also studied here. So we are trying to give back something to the society. This is a CSR. We donated this costing about 1 lakh, more than 1 lakh, because that microscope comes along with a around 50-inch monitor, LED monitor. So we are given that also, so that the student will get interest in the chemistry and biology labs. So we want to build that culture in that village. So this is a small activity what we are doing. And this may contact anytime you want to ask questions, you can ask me questions or send a WhatsApp or a mail, so that I'll be happy to answer it. Okay, to start with, what you can expect is it is impossible for a man to learn what he thinks he already knows. Means whenever we come for a webinar or a training, we have to come with an open mind. We have to unlearn something and then only we can learn something. So even though you may be using it, you may already be knowing so many things about FMEA. There will be maybe some element of it which you would not be knowing. So if you want to understand that, first we have to unlearn and then learn. And today I'm expecting good participation. Maybe after the session, you can ask me questions. We'll have about 10 or 15 minutes of question time. We are planning to stop by after about 1 to 1.25 hours. Then we can ask and go through the questions, because I cannot see the chat box as of now. So what I'll be covering is very minimal about the quality cost. So today's webinar is just an overview of the actual VDA FME. This will not be in detail, because detail it's planned later. That is how it was planned. So today it is just an awareness session and then later on we'll go into the details in a next session. We'll talk about quality cost, little bit of quality cost, how it matters in your design department or your design field, maybe design or process. Then FMEA and NPI and PD, new product development. We'll talk about the existing FMEA, that is 4th edition, even though it is obsolete, that is the current one. Then important definitions in FMEA. It is very important to understand this definitions, both the existing definitions and the definitions related to VDA FMEA. You have to understand the subtle differences between that, which is most of the time people get confused. So we'll see the clear definitions of that. Then we'll go to the VDA FMEA, the changes, additions, what is new in this, what is it that you have to do extra. Then we'll talk very little about DFMEA and PFMEA with respect to VDA. Then we'll talk about AP table, action priority table, which is unique to this FMEA, not in detail again. MSR activity, which is part of DFMEA with respect to VDFMEA, all these are not there in the existing FMEA. Then when are you supposed to change over the implementation timeline? And maybe, if possible, one example, or we can skip that. This is what is planned. You can ask anything you want later on. We'll try to address it. First, we'll talk about quality cost. I think all of you are aware of quality costs. You know the cost of not meeting quality. It is very simple as that. You don't meet anything, whether it is design related or process related or product related, or it may be verification, validation, or it can be anything. If something is not met, this is what happens. You would have heard of the recall of the Audi, Takata recall, airbags recall, Volkswagen scandal. You know what is the problem. Volvo cars recall, BMW, Firestone. You take a product, it has been recalled. Maruti has recalled, Honda has recalled just recently, few months back, and I think yesterday or day of yesterday there was some papers again. I think it was Honda recall. Then Apple phones, Samsung phones, which has been recalled. More than that, Airbus, Boeing, the flight was disrupted. It was stopped because of the crashes. Again, some issues. We'll not go into details because that is the cost which you will be paying for not meeting the quality requirements. This is what happens. The Max disaster cost Boeing billions of dollars. Now there appears to have restarted the production. That is a different issue. But what is it they lost in the matter of 2 to 3 years? Huge loss. Why did this happen? Because of some issue which was not addressed, which you have overlooked. You said, okay, fine, chalta hai, it is okay. So this is what happens. Now coming to your DFSS and NPD program. So where is it? Where does your DFSS NPD fit into your product lifecycle? You take any product lifecycle. It is start till finish. That is, you have some activity which is being done, started, and then till the end. So assume it is a DFSS project that is designed for Six Sigma. That is your NPD or NPI project. NPD means new product introduction or new product development. It's both the same. So you start with the documentation, project scope, business scope, development, scale up, and launch. This is similar to your APQP. It can be any project management lifecycle. So this is at the broad level. So this includes your understanding customer needs, initial solution, model space, all that. There are many activities which goes into the design and development of a product. And FMEA and all those tools which you use will be part of this design lifecycle. For example, you take this NPI process, you have the stage gate 0, 1, 2, 3, 4. This number of stages depends on the product lifecycle. The more complicated the product is, or the more parts the product has got, the assembly has got, you have more number of toll gates in this life cycle. Otherwise, it can be as short as possible. So whatever it is, you have very clear defined stages. That is, you have DFSS, define, measure, analyze, design, optimize, verify. This is your DFSS methodology designed for Six Sigma. So under define, you have various tools to be used. Under measure, you have something, under analyze something, design something where you have this, and optimize some tools, verify some other tools. So analyze, when you come to analyze, you have something which is here, which is your FMEA. When we say FMEA, it is not which FMEA is it? Is it design or process or software or application or which one it is? There are many FMEAs, as I told you. The type of FMEA which you use will be appropriate to your design activity. So this is your NPD process. Now overall objective, why FMEA is required? FMEA is provide a basic familiarization with the tool that aids in quantifying severity, occurrence, and detections of failures. This is as per the existing guidelines and guide the creation of corrective action, process improvement, and risk mitigation plan. And you know, FMEA is a risk analysis tool. It is a preventive action tool. So the more rigorous your FMEA is, any type of FMEA, the better your product will be or your process will be. So it is up to you to see how robustly or how effectively you perform your FMEA. Again, that depends on your CFT, cross-functional team, which is there as part of making the FMEA. You should have good people, that is senior level people who are knowledgeable about the process and the design. Only then you can have a good, effective FMEA. Otherwise, it will not be effective in the sense that many of the parts would not be addressed, it will not be highlighted, it will not be even captured. Now, is FMEA really important? Yes, it is really important because it is required as per law. When you talk about law, the Canadian law stipulates and also the US laws. It stipulates. We'll talk about the law first. Then you'll understand the importance of FMEA. Under Canadian law, manufacturers have a duty to warn customers of dangers inherent in their use of their products in which the manufacturer has or ought to have the knowledge. Manufacturer will be held liable under Canadian law for foreseeable injury or damage caused by products that were negligently designed. That means the onus of the design lies with the manufacturer. If they feel that during investigation that the design was not properly done, it was not reviewed, yes, the manufacturer is liable. Manufacturer is also held liable for many manufacturing defects, for any manufacturing defects. That is the importance what they're having. FMEA is specifically developed for that purpose. To overcome or address these issues, FMEA has been developed. You know that we will not go into too much of details. Next, continuing with the law, it is a duty to warn and duty to know. Again, as per law, under Canadian law, manufacturers have a duty to warn consumers of the dangers inherent in the use of the product which the manufacturer has or ought to have known. That means the manufacturer should have full knowledge about what they are doing, and that means they should understand the product fully well and see what might fail and take preventive action. That is what it means. Manufacturer likewise has a duty to warn consumers where it knows or should know the safety related danger caused by the product negligent design or manufacture or from using it. So it is not a instruction manual, it is not a service manual which has to be given along with the product to the supplier, to the consumer. It is not only that, you have to tell them that if you don't use this properly, this will lead to so and so. That is your duty to warn them. Whether you are a manufacturer of a component or an assembly, it is immaterial. Manufacturer must also advise consumers of any risk, injury associated with the use of product, even where the product is generally safe. You may feel that it is safe, but the person who is using it is not using it properly. It is your duty to tell him how to use it and to ensure that it is fail safe. That is your duty, manufacturer's responsibility. And how do you do all this? It is only through FMEA. Now again, Canadian law says design FMEA evaluates the entire product design at all levels contained within the boundaries of the product. That is your assembly, subassembly, sub-subassembly up to the component level. Scope of design FMEA includes subsystem component level as well as the interface between adjacent components. That is what FMEA does. Critical dimensions are developed from critical failure modes of DFMEA. DVP and R test criteria are developed and confirmed. All these are part of FMEA and that is stipulated in the law. Now coming to that is DFME, designing of a product. Now PFME, that is your process of manufacturing of that product. Process FMEA focuses on the design of assembly, process development, process specification in order to meet the critical dimensions specified in the DFME. You know this already because you're using FMEA, you know how the design flow down happens, how the dimension flow down happens from the design department to the manufacturing department. It is the same. But again, the law states this very clearly. This is an extract from the law. It is not just written by somebody or this is not a copy paste from some website. It is from the law. The scope of process FMEA can include manufacturing and assembly operations, shipping, incoming parts, transportation, everything. You know, process of PFME. PFME includes everything starting from your receiving inspection, that is incoming when it enters the gate till it leaves the gate, logistics, it includes all. That is what is PFME all about. Now, what if you do not do anything? What happens if you don't tell them what will happen? Those who have the privilege to know what to know have the duty to act. It is your responsibility and you are liable to tell because you know about the product, you know what happens, you know about the safety of the product, you know about the usage of the product. So when you know, it is your duty to act. You have to act and you have to inform the customer and keep them updated as to how to use the product. If not, what happens? Now, criminal negligence, if you don't do that, what happens? As per law, criminal negligence, everyone is criminally negligent who in doing anything or omitting to do anything that is his duty to do so. That means purposely, if you are omitting something, if you are not informing something, that means it is criminal negligence. And duty of persons undertaking acts, everyone who undertakes an act is under the legal duty to do so, omission to the law or it may be dangerous to life. So you will be prosecuted. That is the seriousness of the designer. So you cannot take it lightly when you are working in a design for a design or a development of a product or a process. You should be really involved in that and ensure that it is safe to use. And now 4 scenarios are described and detailed in the law. Scenario 1, FMEA is done properly and no significant design deficiency are identified. No legal consequences, it is okay, that means this is fine, no problem. Scenario 2, FMEA is done properly, design deficiencies identified, risk fully addressed. There should be no legal consequences resulting from the FMEA. That means this is also okay because FMEA is done properly. So no problem, you need not worry about scenario 1 and scenario 2. But scenario 3 and 4, you are liable. Scenario 3, an FMEA is done improperly. Means what? You have just done an FMEA naam ke vaste. Auditor has asked for it, customer has asked for it, somebody has asked for it, you just fill up a form and submit it within half an hour. That is your FMEA. That is what most of them do. It is done improperly. No design deficiencies are identified. You not put thought into that. Your safety team is not involved. Only one person is sitting and doing the FMEA. It happens. Every company it happens. Most of the companies it happens. Right? It is only for namesake it is done. Negligence claim can be made that design deficiency were possibly missed due to incompetency of the FMEA procedure. This is scenario 3. Scenario 4 is much more. FMEA is completed. Design deficiency identified. However, the risk from the design deficiency not addressed. It is like a risk register. You identified everything, but no action is taken. There's no plan A, there's no plan B, there's no redundancy built into the system or the process or the design. Nothing has been done. It is just on paper. Negligence claim can be made that the company knew of the deficiencies in design or manufacturing, did not take adequate action to address the associated risk. This is what happens if you don't do this, you are liable to be prosecuted. I don't want to show that slide. That slide from a US attorney says that the person who is doing the design and if he is found to be faulty and he is not taken any action, that means he can be jailed. He can be imprisoned. A number of years of imprisonment that is also mentioned. It is as per law. Maybe in India it is okay. It is not enforced to that extent. Sooner or later it will catch up. So what I'm telling you is the importance of FMEA. It is very important to do a proper FMEA. The more time you spend in FMEA, it is always better for you and better to the company. The biggest risk is of not doing FMEA. Don't be the one who says data or information was not available. Department could not prove it was unsafe to allow the operations. Don't give this excuse. You know what has happened? You know what is this? Challenger disaster. There about 6 astronauts died, 1 Indian. And what was the outcome? They said it was some O-ring problem. Whatever it is, we will not go into details of that. You can always say this is the first time I'm designing. I don't know what happens. There is no data available. There is no prior information. Nothing is available. This is the first time we are designing this product. So how am I supposed to know that it will fail? Yes, very good question, but there's no answer. It is your responsibility, your duty to find out how it can fail. The tool is meant for that. So you don't give the reason that data information is not available and the department could not prove it was unsafe to allow the operation. Whether you are doing the design for the first time or the nth time, ensure that the design failure modes are captured and addressed. Please take that as a rigorous activity, rigorous exercise, and ensure that the documentation is pakka. That is what I wanted to stress. Doing FMEA, everybody knows. You have been doing FMEA for years together, but what I wanted to convey is, as per law, it is required. That means the government is really strict and making sure that your design is okay. It is like a third party inspection. Okay, with that background, let us just briefly talk about FMEA. We'll just see what are the types of FMEA, then we'll go to the VDA FMEA, then see what are the differences. Now, what is FMEA? You know, it is a plan B, it is a backup action. Right? You do something, what is the mitigation plan you are having? What is the redundancy you are building into the system? If something fails, assume that it fails. That is how you build it. That is how you make a robust design. You use all your tools, you use your DOE, you use your Taguchi methods, you use your robust design analysis, you use everything, all tools available. In spite of that, you assume that something fails. If it fails, what is your backup plan? You know the Webb telescope, which was just recently launched about a month back, 1.5 months back. There are more than around 400 single point failures in that project. Single point failure is if that fails, the whole project fails. That is the criticality of that mission. In spite of that, so far it is okay, doing very well, fine. There's no failures. That means they have given lot of thought for each of the single point failures which was there in that mission, in that telescope launch or the construction or the design of the telescope. It involves so many things. The launch vehicle, telescope, antenna deploying, there are so many things which are involved in that. 400 critical point failures, single point failures means it's a huge risk what they are taking, but it is doing well. That is what is required to be done. Now coming to the FMEA, you know it is part of the core tools. What are the core tools? I think you know because, okay, fine, it is all muted, you cannot talk, we'll discuss later. You know what are the core tools? APP and PPAP, you have SPC, you have MSA, you have FMEA here, that includes both process FMEA and design FMEA, then you have SPC. So these are the core tools which people should know as part of your APQP and PPAP. Not only that, you should know this as part of your design lifecycle or product design lifecycle. Only if you do all this, then only your design will be complete or your process will be completed. To understand this, you have to understand 100% Pakka design FMEA and process FMEA. Now some of the definitions, very important definitions which you should understand without getting confused. These are the existing definitions. What is failure symptom? Failure symptom is a telltale indicator that alerts us to the fact that failure is about to exist. That is failure symptom. As the name suggests, it is akin to a symptom of a person, a patient. A patient goes to a doctor with a symptom. That is the failure symptom. That is the symptom. That means the patient has got a fever. That a failure is about to exist because seeing the pattern of the fever or the periodicity of the fever or the intensity of the fever, that means the doctor will be able to diagnose saying that yes, this is indication of so and so, or this may be onset of so and so. That is how the diagnosis starts. There are many things which you can learn from doctors. Okay, I learned many things. My wife is a doctor and learned many things from her. That is a different issue. There are many things which we can learn from each other professions. Actually, I did a webinar on what engineers should learn from doctors. There are many things which they do in a different way compared to engineers. And some of them are really good. We can copy it from them. That is a different topic. Second one is a failure mode. Failure mode is a brief description of what is wrong. Failure mode is what we need to prevent or fix. Always talk about failure modes. Mode of failure is the first thing which you have to address in your FMEA. Not the cause of failure, that is next. The first thing is mode of failure. If the mode of failure is addressed, everything else will get addressed. Next, failure cause or the mechanism of failure. It's a brief word description of why it went wrong. You know about this, you know about the YY analysis, you know cause and effect, you know everything, all those corrective action tool or RCA tools, right? Which are the RCA tools? There are many RCA tools, but most commonly used, everybody uses is your fishbone. But fishbone may not be the right answer for everything. Okay, there are other tools which has to be used other than Fishbone. Actually, that was the webinar of last week. Last Saturday, I had a webinar on why only 5S, why only Fishbone, why analysis. Because why will not address all the problems. There are other tools which is called as FTA, fault tree analysis, which is a very good tool which can be used instead of why analysis. Because why analysis has got some limitations. That limitations people have to understand. But in spite of that, everybody uses why for everything. And that is the reason why you will not get the answer. In most of the cases, you might get it. In some of the cases, you may not get any answer. You will just force fit a tool and say this is the done, and the problem will come back after a month or 2 months. Because every tool has got a limitation. Okay. As I told you last week, I had a webinar on that. And today afternoon also I'm having a webinar on what is not quality. Everybody who have heard of quality, I'll be telling about what is not quality. Today at 1 o'clock. Okay, that is a different topic. That is a separate topic to make you understand what is not quality. Right. Don't worry about that. The failure effect briefly describes the consequence of failure mode should it occur. This is the failure effect. Now coming to the clear understanding of each one of them, say requirement is 4 screws. Failure mode is fewer than 4 screws were used. You used only 3 screws. That is the failure mode. Effect of that is loose seat cushion or something, assembly, stop shipment or additional sort. This is the effect or the end effect which happens maybe in the shop floor, in the line, next assembly or at the customer. So we have to talk, we have to address not this, we have to address this. What is a failure mode? How can you prevent this? Similarly, specified screw is a requirement. You have to use the M6, M8, M10, something. Failure mode is wrong screw used. Effect of that is something happens. So FMEA addresses this failure mode. That is why it is called as failure mode effect analysis. If this failure mode happens, what is the effect? Similarly, etc. etc. So this is only to explain the difference between what is the failure mode and what is the failure effect. Both are not the same. Remember very clearly that we have to address failure mode instead of effect. Next, severity is an estimate of how serious the impact of the failure effect would be. You know about that because you have been using the FMEA tables, you know severity, occurrence, detection. You have used the severity table, occurrence table, detection table, right? Product of that is RPN. SOD product is RPN. Based on the RPN, you will take action. That is what is the present FMEA. Occurrence reflects on the prediction of each of the failure occurring based on the type of control. That is severity occurrence. Next one is frequency of occurrence. This definition is extra, which is not there in the present FMEA. This is part of VDA FMEA. Frequency means is a measure of likelihood of occurrence of the cause in the relevant operating situation during the intended service life. That means likelihood of occurrence of the cause in the relevant operating situation based on the intended life. How frequently it is occurring. This is not the same as occurrence. Next one is detection. Again, this is the existing one. There is no change in the definition used to depict the relative effectiveness of the symptom to prevent the failure mode. Monitoring M. This is extra. This is in VDA-FMEA. Monitoring is a measure of ability to detect the failure, fault or effect during the customer operation and applying the fault reaction in order to maintain a safe compliant state. This is your monitoring mechanism which is extra, which has to be done as part of VDA-FMEA. Next, your MSR. MSR means monitoring system response. Is intended to help maintain a safe state or safety and a state of regulatory environmental compliance during customer operations. So in VDA-FMEA, two things are important. They ensure that safety is number one. Number two is regulatory. So when you go to the rating table, that rating of 10 is given for safety. Rating of 9 is given for regulatory compliance. So 9 and 10 are reserved for these two. Similarly, in your existing FMEA, SOD, severity occurrence detection, 10 is reserved for the failure without notice or without warning. Right? that is number 10. Similarly, in this FMEA table, safety and regulatory are reserved for number 9 and 10. Rest of the numbers you can assign. There are some of the definitions which you have to remember. Just to correlate those definitions and make it more understandable, you take an example of equipment. A furnace or the tube boiler is an equipment. What is failure? Means what happened. Catastrophic failure of the welded joint. That is the failure. Mode of failure by definition is what equipment failed from. That is the mode of failure. Maybe corrosion fatigue is the mode of failure. Because of fatigue, this welded joint gave way. Next, root causes. You do a YY analysis, fishbone or anything. You identify the causes for that. Maybe the reason can be poor feed water or rapid firing or particularly from cold, etc. Overpressurizing, temperature cycles. There are so many things which you can come out as a root causes. This is root cause. Next, MSR by definition. What is MSR? Okay, you cannot answer. Monitoring system response. Monitoring system response by definition talks about your safety and compliance. So that means having a warning system for safety, not for exceeding number of hours, etc. That is for compliance sake. So these two have to be addressed in your FMEA process or your design process. So monitoring system response means what is it that you monitor in your system and what is the response you are getting. That is what is MSR, and this is only for DFMEA, not for PFMEA. Now, when to use FMEA? You know when it has to be used is part of the design FMEA, process FMEA, SPC. So you have the potential F defect, we have the internal defect, you have the external defect. So the cost which you incur may be initially 1, 10, 10 into 10 into 10 into 10. So the moment it goes to the next stage, it gets multiplied by 10. So it is always better, it is advisable to use all these tools, process related, design related at the initial stage to avoid a greater failure or to avoid the cost incurrences later on. This will be a huge cost because you have to recall the product. It is not easy for recalling a product. I showed you that in the initial stage slides. It is not cheap to recall a product. It is a huge expense to recall any product which you manufacture and give it out to the customer. Because all the products which are manufactured from this date to that date has to be recalled wherever it is sold worldwide. To avoid that cost, you have to do everything initially at the beginning of the product life cycle. That is quite natural, common sense. We need not stress on that. Now coming to FMEA, it says, why does it always seem to have plenty of time to fix the problems, but never enough time to prevent the problems by doing it right the first time? What is the problem that you are having? People always say, right the first time, do it right the first time, every time. There are so many jargons, so many slogans which is there just on paper, but is it that it is not happening in practice? Maybe you have a lot of issues, maybe you have time constraints, you have pressure constraints, your boss is telling you finish it within 4 o'clock before you leave for the day, etc. There are many things which helps you to jump the gun. Okay. Now FMEA is and cost of quality. I told you about the cost of quality initially. So, and I told you about the effect of FMEA. If you don't do, what happens? How is it related to the cost of quality? And what is cost of quality? Whether you call it a COQ or COPQ, cost of quality or cost of poor quality, it is all the same. Ultimately, it will be the same. So that got while the immediate benefit of FMEA is the mitigation of risk. This is because FMEA is a risk mitigation tool, as I told. It should translate to reduction of the cost of quality. Finally, it should lead to reduction of cost of quality or cost of poor quality. Cost of quality is made up of 4 components. Prevention cost, appraisal cost, internal cost, failure cost, external failure cost. What are these? I'll show you in the next slide. Effective FMEAs lead to reduction of internal and external cost, which is known as cost of poor quality, COPQ or COQ. These are associated with your both DFMEA and PFMEA. It is not entirely dependent on one FMEA because both are related to each other. Whatever you design has to be produced, has to be manufactured. So whatever you have identified as during DFMEA has to be produced and met in your PFMEA. It has to be addressed in the subsequent areas, right? In the subsequent processes, it has to be addressed. You cannot leave it open. So in efficient FMEA, you see the failure cost will go down substantially more than the corresponding increase in the prevention and appraisal cost. Initially, it may appear that you are spending more, but finally it will be much, much less compared to the final product. This is what you should remember. Don't assume that you are spending more or more cost or spending more time. It may appear to be like that, but in the long run, it pays. So it should be a clean tool for the management to evaluate FMEA, both for its effectiveness and efficiency. What is the difference between efficiency and effectiveness? Okay, fine. I think, sorry, your mics are muted. So I think you know the differences between effectiveness and efficiency, right? Efficiency means the process of the working. Effectiveness is ultimate goal. We'll just share a short video of this. Maybe it will help you to understand what is effectiveness and what is efficiency. This is all from WhatsApp group. If you're a member of WhatsApp, you'll get all this. WhatsApp Unis. Okay, very short video. I hope it will make you understand the difference between efficiency and effectiveness. In this video, what you saw, whether the process was effective or efficient. I think you know the answer. It was efficient, but not effective. Efficiency talks about the process. How you reach, what you want to do, how you want to do in order to achieve the result. That is your efficiency portion of it. Effectiveness is whether it is really effective, whether the SLA's KPIs have been met, yes or no. That is all is your effectiveness. So working towards a target is effectiveness. Whether the target is met or not met is your effectiveness. How well you have met the target. What is the delta? What is the scope for improvement? Why is it not you're not able to meet the targets? That talks about your effectiveness. You may work for 4 hours a day or 6 hours a day, it's immaterial, or even 10 to 15 hours a day. As long as if you don't meet the requirements, that means you're not effective. Nobody bothers about how many days, how many hours of work you put in. Okay. So what we talked about is your cost of quality. We talked about the cost of quality. Cost of quality is good quality and poor quality. You have the prevention cost. Yeah, you have the prevention cost, appraisal cost. Under this, you have APQP, FMEA, FTA, all these tools which you will be using. Even this is the cost you will be incurring, but FMEA is under this preventive cost. It has to be done, which is again part of your cost of good quality, because if you do this properly, finally you will be avoiding this. Then appraisal cost, then internal failure cost, external failure cost. Internal failure cost is whatever fails inside the company before it reaches the customer. External failure cost is your customer returns, customer failures, field failures, and all that, which comes back as customer returns. So this is very, very bad. This should not happen. Next, this also should not happen. If you don't want this and this to happen, you can invest on these two costs. This is what I told you in the previous slide. Even though you have these costs associated with doing all this activity, it pays off because it prevents these costs from happening. And this is a major cost. This talks about your product recalls, especially this customer failure or the external failure. Okay, fine. We have talked about FMEA, the importance of FMEA, the cost associated with that, COQ and COPQ. And in order to this, what you have to do, the process have to be both efficient and effective. Now we will talk about AAG VDA FMEA. In short, we will see what are the differences of your VDA FMEA. How is this different from your existing FMEA? You know about the existing FMEA. We will not go into details of the existing FMEA which you are using because you know the format, you know what has to be done. You have SOD, severity, occurrence and detection. You have 3 tables, one for severity, one for occurrence and one for detection. Normally, most of the time it will be maybe same table or slightly different. So based on the 3 tables, you select severity, occurrence, detection. Product of severity, occurrence and detection will give you an RPN number. So based on the RPN number, the higher the RPN number, you will take the action and mitigate that issue and go forward. That is how you do an FMEA, right? That is your existing FMEA. Now we will see what you have to do using your VDA FMEA. What is not to be expected? We will not cover the product design lifecycle, design for quality, robust design. Again, this is part of FMEA. If you want to have a really good FMEA, you should know this. Not FMEA, design process, life cycle. DFMEA, you have to understand the process, the fast diagram, functional diagram, function tree, boundary diagram, interface matrix, P diagram. These are all very huge topics, very big topics. It will take about 1 day, 1.5 days, 2 days. So to give a brief example of this, you come out with a block diagram. Any system you take, anything you want to design, first you start with a block diagram. Block diagram tells you what is in scope, what is out of scope, what are the boundary conditions, what you have to address, and what are the noise factors and what are the external factors. It talks about all this. Next, system block diagram. From there you come out with a system state flow diagram of the activities or the design parameters. Next, you come out with a boundary diagram. Boundary diagram talks about the boundaries of the project, boundaries of the, suppose you're designing a valve for an engine cylinder. So piston and valve will be the boundary, and out of that all the cylinder liners, everything will be out. Okay, so depends on what you want to focus, what is in scope, what is out of scope. That is your boundary diagram. Once you have a boundary diagram, then you come out with a function tree. Function tree is from top to bottom, what are the failures, what are the function of each of the activities. How is each of the component related to each other? How are the functions related to each other? That is what you have to evaluate. Once you do that, then you have the interface matrix. After interface matrix, you have the interface table. From this will become your end. This is how you do all these activities. And next, PFMEA. From DFMEA, the input goes to PFMEA. In PFMEA, you come out with a process, design verification plan or design validation plan. Then you have a control plan and all that. That will lead to your robust design. Then finally, other types of FMEAs, if required, a software FMEA, application FMEA. There are many FMEAs which will be done. Okay, all these are required for your NPD program. New product development, these have to be done. So when you talk about FMEA, you have to understand these things before you talk about FMEA, because these are the prerequisites for your design FMEA. Not straight away filling up the formats. That doesn't make sense unless you do all these diagrams. Unless you understand this, it doesn't make sense in filling up the format. Format is just for namesake, but you have to do the initial groundwork. Okay. Now coming to the types of FMEAs. The major types of FMEAs is design process FMEA. Under that you have design FMEA, you have process FMEA. Design FMEA talks about your system, subsystem, component level. As I told you, process FMEA again, assembly and manufacturing, same system, subsystem, component, system, subsystem, component. So anything you do, it has to be top down, or it can be even bottoms up, anything. So it will be at system level, that is your higher assembly, sub-assembly, sub-sub-assembly, sub-sub-sub-assembly, component level. Okay, then coupled with all this, for process FMEA, your machinery FMEA will be done. This is not easy. Very few companies do that. Bosch does it. And very few companies have seen people doing it. It is not easy. It talks about your machine. It doesn't merely talk about your machine and process capability. It talks much more about the machinery aspects. This is your machine FMEA. Now, for example, to take to tell you about assembly and manufacturing. I mean, system level, subsystem level component. Assuming you are making an FMEA of a car, complete vehicle. How will you do that? First, you have the system level and subsystem level, subsystem level like that. So once you have a car, the next system level will be, say, steering system, braking system, seating system, next transmission system. So all that will be system level, right? So when you talk about engine system, that is maybe one subsystem of that. Subsystem will be when you talk about engine, your piston, cylinder, valve mechanism. Next to your combustion chamber, the combustion mechanism subsystem, maybe something else, the fuel injection system, that is another one subsystem. Next, when you come to that subsystem will be something else. Finally, we'll end up with your valves, cylinder, liner, fuel injection pump, maybe injectors, all that will be component level. So that is how you come from system or top level to system, subsystem, subsystem, then component. This is how FMEA is done. Any FMEA, any type of FMEA, in any company, that is how it is done. This we have already covered. I told you about system FMEA. It talks about product specification. That describes essential product features, design requirements, components, and subsystems. All these are covered in your system FMEA. That is your top level FMEA. Next is your DFMEA. It is used to develop a. After this, you come out with a DVP, design verification plan or design validation plan. It is a method used to gain confidence in the design. That means what? How do you get confidence in the design? By having a proper DVP. DVP tells you what have to be tested, what has to be validated. It depends on your design. Should you validate this item or this product for what specification? What are the tolerances for that validation? How did you arrive at that validation plan? How did you say it is tolerance of plus or minus 20? Why can't it be plus or minus 30? Wider the tolerance, better it will be cheaper. Or why cannot it be plus or minus 10? Do you want a shorter tolerance? We want to have a tighter tolerance or a loose tolerance? What will happen? If you have a tighter tolerance, the cost will increase. Is it necessary to have a tighter tolerance? That again depends on the design. Depends on what the designer wants. All that will be part of your DVP. That is your product testing analysis. Next is your PFME, everything to do with your manufacturing. That is your control plan. What will be your control parameters? What will be your testing? What will be the sample size? How will you do it? When will you do it? At what batch will you do it? Once in how many numbers will you do it? Etc. Etc. Everything about your process. It maintains the process capability to detect the non-conforming products, NC products or NC parts. Next is your FMEA. It talks about your maintenance of the machine, maintenance plan. Maybe it is annual maintenance, preventive maintenance, breakdown. There are hundreds of maintenance. What type of maintenance has to be done, how it has to be done, when it has to be done. After maintenance, what should you do? How do you restart a machine? All that is part of your machinery FMEA, MFME. Similar to this, you have software FMEA, you have application FMEA. There are many types of FMEAs. We will not bug you with that. You don't worry about it. Okay, now the major changes in this FMEA, VDA FMEA compared to your existing. Number one is your VDA FMEA talks about different steps. First one is scope definition. Then it talks about structure analysis, function analysis, failure, risk, and optimization. These are the various steps which are there in your VDA FMEA. None of them were there in your current FMEA. We will talk about each one of them later on in brief. We will tell you what each one stands for, what you have to do in that. Next is your FMEA form. Not much of change, not a major change in the header and footer and scope definitions. Scope definitions added new in this form. It was not there in your existing format. And whether this, it was already there. So not much of change. It is just a cosmetic change. You leave it, no problem. Next, structure analysis. This is a major change because structure analysis itself was not there in the previous FMEA. So for DFMEA, item is to be expanded to system or system level, system element and component element. So each item means the component under design. That is called an item. The item is expanded into, when you say item, this is the, say, I'm doing FMEA on a shaft. Shaft is expanded into shaft system, then shaft element and shaft component element. So each of them is again subdivided into three levels. For PFMEA, it is expanded into process, process, process. So process item is for the system. Process step is for the system element. Process work element is for this component element. So for each one, because process FMEA, PFMEA is obviously for process, right? So whatever you write here, 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 you have to have a corresponding process, process, process. So it is very easy. You need not do whatever you design has to be, you should have a process for that. Next is function analysis. What do you do in function analysis? For each of the design FMEA requirements, what you are identified above in the structure analysis, it is expanded to function of the system, requirement or input, function of a system element, then function of component element. Again, function of this, function of this, function of this. You identified the element, you identified what are the elements, what are the system level, what are the next level, what are the next level. You identified the process for each of them, process for this, process for this, process for this. Next, you have to identify the function, function of this, function of this, function of this. Function means what is very simple as to what is it supposed to do? What is that component supposed to do? What is the function of that component? I told you all that will be captured in your boundary diagram when you talk about doing a real FME. That will be already captured, or that will be captured in your fast diagram, functional diagram. Functional diagram is meant for that, to capture the function of the components. Once you do this function analysis, next obvious step is to have a process for again that. What is the process for the focus element, function of the present step, and function of the work element? Okay, so you have to have the process. You have to have the function for this one, process for this one, process for this one, process for this one. For each one, you should have a process. That is your again DFME and PFME. First is whatever you do for DFME, you should match it with your PFME. Next major change is your failure analysis. Again, same 3 steps process. We have a focus element. Focus element means the same element which is in focus for which you are doing the design. So in that the form should be failure mode, effect, and failure cause. You know the mode of failure, effect of failure, and cause of failure. So once you know this mode, effect, and fault, you should use the corresponding table for that and come out with the numbers. Then change of the flow, the structure analysis to function to failure cause. This analysis, this is new in this. That is nothing but your flow of your FME from structure analysis to function analysis to failure analysis. That is a sequence of flow. So nothing great. That is how it is structured. It is logical sequence. Next one is risk analysis. You know, FMEA is a risk analysis tool. So you have a severity rating, you have a 10-point rating scale. So based on that, you identify the risk involved in your DFMEA, MSR, and your PFMEA. So you have a different table for each one of them. In your existing FMEA, there is only one table. Here you have different tables. I'll tell you where the tables are next. Next one is occurrence rating. Occurrence rating is a 10-point scale similar to your existing FMEA. Preventive controls are added new. It was not there earlier. This is added new. FMEA MSR replaces the occurrence rating scale with the frequency rating scale. So earlier you had only the rating scale, that is SOD, right? SOD. Severity, occurrence, detection. So instead of this scale, it is replaced with frequency rating scale. This is a new scale which is added, which replaces this, that is your FMEA MSR. Next, detection. Again, you have a detection. There was a 10-point scale for detection. You had a table for that. So instead of this detection rating scale, you have a monitoring rating scale. You may feel that both are same. It is almost same. Detection is replaced with monitoring. The wordings are different. It is not only wordings. The way it is rated is also different. When you see the table, you will understand. That is, the tables are available in your AAG manual. Then replaced RPN number with AP type number, action priority number. So you had an RPN number earlier, that is product of SOD, right? Based on this RPN number, you used to take action. Now that is replaced with action priority, that is AP number. You have a table for this to select AP number. AP, that is action priority. It is high, medium, low. So if it is high, make it medium. If it is medium, make it low. It is exactly same as a risk analysis table or chart or methodology. Even in your risk analysis, you do the same thing, right? High risk, you reduce it to medium risk you reduce it to low risk. Next, you have optimization. The last one is optimization, which which has two columns: preventive action, detective action. That is your optimization. So for each of the activity, what is your preventive action you have in place? What is the detective action you have in place? Next column talks about the status. Status is untouched, under consideration, progress, completed, discarded. So you have to fill up the status saying that whether the activity is done or not done. The last one is your special characteristics, which is there in your FMEA, which is not there in DFMEA, but it is there in PFMEA. It is removed in DFMEA, but it is present in FMEA. So this should remember, special characteristics is there only in PFMEA because it is required as part of the process control parameters. So these are the major changes in your VDA FMEA. Now, how is it structured? AAG VDA FMEA or regular FMEA, also you had DFMEA and PFMEA. But in VDA FMEA, you have DFMEA, PFMEA. DFMEA is also supported with FMEA MSR. So what does these two tables? For DFMEA, you have severity, occurrence, detection, and action priority. You have SOD tables for this. Similarly, you have SOD, severity, occurrence, detection, and AP table for PFMEA. So you have three tables here, three tables here. Okay. Now coming to FMEA MSR, again you have severity, frequency, monitoring, and action priority. So you have three more tables here. So that means to say you have 9 tables to be used. Instead of earlier FMEA, you had only 3 tables, one for severity, occurrence, detection. You have 3 different tables, 9 different tables, 3 for this DFMEA, 3 for PFMEA, 3 for FMEA MSR. So when you are doing design FMEA, you have to use this. This part will be part of your design FMEA. And when you are doing PFMEA, it will be only this. Will be your PFMEA portion of it. Because the rating tables are different for DFMEA, PFMEA, and FMEA, there are 3 associated AP tables. So you have action priority table for this, for this, for this. You have 3 action priority tables. If you are doing DFMEA, use this AP table and this AP table. Then if you are using PFMEA, use this AP table. Okay. It is not very complicated. It is easy because tables are available. Tables are standard. You cannot change the tables. You can't do anything with the tables. Similar to the previous table. You have to use only that table. And just pick up whatever the numbers in that table. You write that number. The only thing you have to remember that is these tables are different. Not unlike the previous FMEA where you had only one table for everything. That is the only difference. It is not a rocket science. Now, why is it revised? Why is it a change of methodology? Just to give you an example, you have SOD, the existing FMEA. You take 2 cases. You have severity, occurrence, detection. 844, RPN is 64. Next case, something, RPN is 64. You have the same RPN number with the different severity, different occurrence, different detection. What do you do with the same RPN? Which one do you address? Will you address this first or will you address this first? You say that you address this first because severity is high. That is the normal thing. That is the intuition. May be right, may not be right. So in this case, what you do in VDA FMEA, since the RPN is same for both the cases, RPN is not sufficient to differentiate between SOD combination. That is the reason why you are having
Hello.
I think there's a technical issue.
Sir,
Speaker
your
will
voice is
be.
not audible. We cannot hear you.
I think he left and he's joining back. There must be a technical issue.
Guru sir, are you there?
I
No, I
think
think he
Ashish,
left.
some technical glitch has happened from him.
Let
He
me
has
check.
logged out and he is going to get logged in.
Yes, I think he's joining back. For the participants who are asking in the chat box, there must be a technical issue. Mr. Gurur will join us shortly. And yes, we will share the link of this recording. It's on our YouTube channel, NBQP YouTube channel. You can visit there and you will be able to see this video recording over there. Mr. Gurur will join shortly. There must be a technical issue.
Yeah, is it visible? Can somebody tell me? Because the problem is I cannot make out if something has gone wrong.
Your screen is visible, sir.
Yeah, because I don't know when it was disconnected because there is no audio, video, nothing. I'm not able to listen to anybody. So I
You
was
are
under
audible and
the
your screen is
assumption that
also
everything
visible.
is okay, so I kept on talking to myself. Right? Okay, fine. I don't know where it was left out. idea? I think this slide, is it clear? Somebody should tell me.
Yes, sir.
Was this covered? Were you able to hear to listen to this slide when I was talking?
Slide number 80.
Pardon?
Slide number 80.
Yeah, this one.
Yeah, this one. Yes.
Yeah.
Yeah, this was okay, right?
Yes, this was okay. Was
Okay,
that?
fine.
Yeah.
Next is this.
Yeah.
Should I restart from this?
Yes.
Okay, fine. I'll restart. I think I lost about 5 minutes, no problem. The reason for coming out with this table that is called as action priority table. You have severity, occurrence and detection, and you have AP, that is action priority. To just give you an example, you take an example of 10.4.2 RPN as 80. So 10.4.2 comes under this category, 10, 4 and 2, because 10 is covered under this, 9 and 10, 4 is covered under this, and 2 is covered under this. So this into this into this gives you RPN as 80, which is considered as medium. Action priority is medium. The whole scale is in this table, complete. This is just for clarity purpose, only 2 are mentioned. The next you take an example of 3, 8 and 5, which is RPN of 120. 3, 8 and 5 comes under this. 2 to 4 is 3 comes here, 8 comes here, 5 comes here. This is listed as high. So that means to say in this VDA FMEA, even though the severity is low, the action priority is high. Unlike your previous FMEA. Previous FMEA, since 120 is the RPN number, so this is high. This is low. Right? But you take action on this because severity is high. But unlike that, in your VDA FMEA, whatever is high, you take action first. Then whatever is medium, you take action next. Or either way, you can do whatever you want based on your convenience and based on your bandwidth, you can take whatever action you want. But the structure is like this. Next, determine the action priorities. There are some things which are still debatable in this VDA FMEA. Some say this is good, some critics say it is bad, it is not very good. The debates are going on, even though this is released by AAG, there are still debates going on. So we'll not go into that. But to give you 1 or 2 points, the upside of this, the manual explains how logical should the dictate priority of action should be compared to RPN. This is the upside of it. And the downside of it is when in use, the spreadsheet itself only shows the ranking numbers and the final RPN. The direction is back to the manual, that is your old FME. So they say this is a combination of 2 RPN, 2 FMEs, the existing FME and new VDA FME. So unless the company establishes its own procedure to give the team a method of prioritization, the highest RPN can be still used. Yes, you can still use and fall back on your previous FMEA. You can go back and say this is the highest RPN number, I'll take action on that. It is much valid. You can do whatever you want, whether you want to follow RPN methodology or action priority number, high, medium, low. The choice is yours. That is the downside. Next, the AP table. AP table was built that is logic based. You can see the logic in this table. And it follows the same occurrence detection rating criteria. Then to make this more manageable, that is your occurrence, severity, occurrence and detection, such as severity of this, detection of this and occurrence of this, all 1000 possible combinations are listed in this table. You have 1000 combination, right? 1 to 10, 1 to 10, 1 to 10. What is the highest? 10, 10, 10. 10 into 10 into 10 is 1000. So that is all 1000 possible combinations are listed in this table. One table will give you all combination. Similarly, as I told you earlier, you have 3 tables, one for DFME, one for PFME, and for one MSR activity. The logic is recommended, the manual is built into the table. Then users and the spreadsheet and software to follow them on the logic are based on high, medium, low. So that is the advantage what you get in using this action priority table, FME. This is some of the changes. And the methodology, it follows a 7-step approach. 7-step approach means what are the 7 steps in this? 7 steps are step 1, 2, 3, 4, 5, 6, 7. Starting one, planning and preparation, structure analysis, then function analysis. So that comes under your system analysis. So it talks planning and preparation covers the scope of the definition of the project. It is same everywhere. It is same scope definition, planning definition is nothing but your project definition. Whether it is a Six Sigma project or your 7QC tools project or your Kaizen project, it is same. That is, you have to plan and have the scope for the project, right? That is your step one. Then step two talks about your structure analysis, which is used to identify and break down the system, whether it is DFMEA or PFMEA, into your system, subsystem and component level, which I explained earlier. And it gives you a complete comprehensive risk assessment that can be conducted. Because FMEA is a risk analysis tool. That is your structural analysis, step two. Step three is your function analysis. That is each of the system element identified in step two, you come out with a function. What are component you identified here? You come out what are the functions for that. Right? It can be anything. It can be assembly, subassembly, sub-subassembly, component, anything. So whatever you come out with in step two, you come out with the functions of each of them. That is your function analysis. All these are part of your system analysis. Step number 1, 2, 3. Next 4, 5, 6 comes under failure analysis and risk mitigation. So what is step 4? Step 4 talks about your failure analysis. At the beginning of the next step is your risk mitigation. The purpose of failure analysis is to identify the failure modes, failure effect, and failure causes. Identify all these three, which is the basis for risk analysis in the next step. So in this step 4, you identify failure, effect, modes, and causes, similar to existing FMEA. Step 5, use your table, use your action priority table, and come out with high, medium, or low risk priorities. Risk priority or action priority. So in this step 5, use your AP table, and whatever you identified here, use this table and come out with high, medium, low. Sixth one is optimization. Optimization step where the plans are developed that reduce the risk and increase the customer satisfaction by improving the design or the process. Whether it is DFMEA or PFMEA, you optimize the process or optimize the design. Okay, this is what you do in 6. And 7 is just documentation. That is for communication or closing the project. So it is a very logical sequence of activities what you are doing in this FMEA. Again, I told you it is not a big change compared to your present FMEA, but the sequence of activities and the way it is structured makes all the difference. So first it is system analysis, failure analysis, then communication. This you leave it. This is documentation. So you plan for the project, what has to be done, identify the structure. For each one of them, identify the function. For each one of them, identify the failures, because whatever function is failure of the function. You're talking about not failure of the component. We are talking about failure of the function. Suppose the function is to hold two parts together. Function of a bolt. You identify the component as a bolt. The function of a bolt is to hold two parts together. That is the function. Failure is it is not holding together. It is coming apart. So that is not failure of this. It is failure of the function. So once you identify the function, next is the risk analysis. Coming out with your SOD table and your action priority. Once you put that in place, you take action, you optimize your design or the process. See in what other better way you can do. What are the options? If there is nothing, leave it. Then the last one is your documentation. This is what you do in FMEA. So benefits is increasing multidisciplinarity, more risk can be addressed, technical guidance. There is, we have seen all this. What are the benefits of the 7-step courses? It is more logical. So it looks like this. I'll show you the format later on. So it is step 1 is definition. This is common for both VDA FMEA and DFMEA and PFMEA. Structure analysis, function analysis, failure, risk, and optimization. So where does it fit in? Your team scope of the existing FMEA fits under this planning scope, planning and preparation. Structure analysis comes under PFD. Function analysis is part of your this. This is your existing one. This is your new one. So then your failure analysis is part of this, which is already you are doing it. Risk analysis, you are doing this earlier. All this is part of risk. Optimization, you are doing this earlier. So it is just restructured, whatever you are doing. Now DFMEA, just 2 slides about each of the FMEAs. You have the design process, you have process development, manufacturing, usage of product. This is your top level process approach. That is your NPD lifecycle. In your design of the process, you have data, design data, where you have comes back to design. Right. Similarly, your process, you do the manufacturing, your planning data, it comes back to the process for optimization. So feedback can be either from here, or it can be from here, or it can be from here. So it depends on the type of product, depending on the type of methodology used, it can be anything. So this is how your DFME or PFME is structured. This is how the spreadsheet looks. I'll show you another spreadsheet later on. Next, MSR, it is similar to your DFME. MSR is your measurement system response. System response, measurement of system response is how good your design is. What are the failure criteria? How are you addressing the failures? So the failure you address can be in the form of Pokayoke, it can be in the form of prevention, or it can be in the form of detection. It can be anything, but all these things have to be built into your design FME. Means if you are designing something, it can fail because of this. So how are you mitigating that failure? What is your backup plan? That should be part of the MSR activity. We will not go into details, that will be too much. Next, again, the steps are similar to DFME. It is definition, scope, system analysis, structure analysis, function analysis, failure analysis, risk analysis, optimization. Everything is same. Nothing will change except for some of the activities which you do under this, it will change. Very few activities will change. Otherwise, it is same. The methodology is same. The activities will be same. Next, PFMEA. Under PFMEA, you have the system level FMEA. That is your top level FMEA. That is your QFD. That is level 1 QFD. From level 1 QFD, you come to level 2 QFD. Under level 2 QFD, you come with a DFME. Next, level 2 QFD, from there you come to a level 3 QFD. That is your process level. Once you come to process level, you come out with a PFME. For PFME, you come out with your documentation. This is how you structure starting from QFD. This is your design process. This is nothing new. I'm not telling anything new. This is your existing methodology, what you are doing, right? This is what the customer wants. That will be captured in the form of QFD. Once you have this QFD, that is the top level. Next, system level, subsystem level, subsystem level, or the component level. This is your component level, the final level. So once you have the final level QFD, you come out with a process control plan, DVP. From here, you come out with your work instruction, formats, template, checklist, and all that. This is how the flow down of the document or the life NPD program will be. So in each of the stages, whether it is DFME or PFME, you have to appropriately use the tools. What is PFME? We have seen what it is. You know what is the objective and purpose: to identify the potential modes of failure, inputs of failure, when to use after completion of the flow diagram. That is your after the completion of your DFME, you use PFME prior to tooling for production. Prior to this. This is how the flow chart, the complete template. I'll show you the template, Excel template. Now transition strategy. When to use this FME? Are you supposed to use it or no? As per the OEM manufacturers, you are supposed to change over from existing FMEA to this FMEA. It is mandatory. Fiat says timeline is 19. This is already over. They started using it. All suppliers for Fiat. Similarly, future programs sourced under beginning 2019 for Fiat, you have to use DFME and PFME as per VDA FMEA guidelines. Ford will accept the existing format, new format, making new FMEA format only. Suppliers will require to utilize the AAG format on the per program basis starting from 2022. From this year onwards, Ford suppliers will have to use VDA FMEA. Otherwise, they will not accept. It depends on the customer to customer. You can always talk with your customer. Honda Honda will accept new AAG format anytime. They already changed over. From February 22, suppliers will apply the new AAG VDA format. You have to use only this for Honda. By 27, all PFM documents are in the new VDA format. By 27. So most of the suppliers, they already started changing over. GM, implementation beginning with this program to start in calendar year 2023. Next year, GM will change over. So depending on whom you are supplying to, based on the customer requirement, you'll have to change over to this VDA. I will show you the format now. Then we'll take up any questions. Okay, I'll just show you the Excel sheet. Yeah, can you see the Excel sheet? I think now you can unmute.
Yes, sir, it's visible.
Yeah, all of them can be unmuted.
No, sir, we won't be unmuting everyone because we have around 400 participants.
Okay, then we'll talk.
If it is a training program, then we can give access, so we can unmute everyone. Right now, they can type their question in the chat box.
Okay, fine. So this is your FMEA format. Structure analysis, this is your DFMEA format, then PFMEA format. It is similar. You have the next level. Structure analysis, that is step 2. First one is your documentation, that is your scope. So there is nothing to enter here. Step 2, higher level, focus element, next lower level. You have to enter here. The next one is your function analysis. Function analysis, again 3 levels, you have to enter. Then failure analysis, scope and effects of failure, severity of failure. Next, you have failure effects, current prevention control, then detection control, then you have occurrence and detection. Then DFMEA, that is AP, this comes from your AP table. So based on this severity, occurrence and detection, you get the AP table. Next, you have preventive control, deductive control, responsible, target dates, status, and completion date. After that, again, severity, occurrence, deduction, new AP table, new AP number. So this AP number should be lesser than this AP. It is similar to your existing FMEA. This RPN number should be lesser than this RPN number, right? So similarly in this. So this is the complete list of the format which you have to use, the new format. Similarly for PFMEA. PFMEA also, it is exactly same. There is no difference in this. Everything will be same. Only difference will be special characteristics feature. This was not there in your DFMEA. So that is included in your PFMEA. Except for this, everything else, all the columns will be same. Responsible person, target person, optimization, completion date, severity, occurrence, detection, new AP. Okay. So this is how the new format looks. You'll have to fill up. It's a huge format. It is not as simple as your existing FMEA format. And lot of activities to be done. But as I told you, it is a good methodology if you want to use it, and it will help you to be more logical and identify the problems. Okay. Yeah, anything else you want to ask now?
Yes, so there are quite few questions. Let me just quickly go through. I'll do that for you. So there's a question from Manthan Sanghvi. Is there any guidelines or rules which NCM methodology to be used or referred for FMEA? For example, YY, fishbone, etc.
No, fishbone YY is part of the FMEA tools. Fishbone analysis is always used for cause and effect, to finding out what are the causes, what are the problems and all that. The tool will always continue to be used as it is. There is no change in those tools. You can use fishbone YY analysis, you can use FTA, you can use is not analysis. There are many RCA tools which can be used. That is apart from whether it is existing FMEA or VDA FMEA, it is immaterial.
Okay. Another question is, does calibration come under prevention cost or appraisal cost?
Calibration is not part of this. Calibration is not part of FMEA.
Okay.
Calibration is actually a preventive cost because you are doing calibration in order to have a problem of uncalibrated instrument being used and the defective part going to the supplier, going to the customer. So it is a preventive action tool. But that is not part of FMEA.
And another question is this new AI, AG, VDA, FMEA applicable for both design and process?
Yeah. I showed you there are different types of FMEA, VDA FMEA or process FMEA, design FMEA, process FMEA, and software FMEA, machine FMEA. There are many types of FMEA process. You can use any type of FMEAs for this.
And could you please share an example of DFMEA and PFMEA, how the structural, functional, and failure analysis is done?
Example.
Yes,
Okay. DFMEA, there's one something. Shall I show you the presentation?
Sir, you can explain this in brief, sir, because we have paucity of time also.
No, to tell an example, I'll just show you an example. Can you see the format?
Yes.
Okay,
Yes.
this talks about your structure analysis. Example is a window lifter. The focus element is one of the component in the window lifter is the commutation system. In this, the lower level, next level component is your brush card. These are the component level. This is your system level, subsystem levels, component level. So function of this brush card is converts electrical energy to mechanical energy. Function of this one is computation system is to do this. Next lower level function is of the brush card is to do this. Okay, this is what is the function which you identify for each of the components what you identified in the previous step. Similarly, each step is related to the previous one. Okay, this is what we are talking about DFMEA. Similarly, for the process FMEA, in the process FMEA also you identify this with respect to the process. What is the process involved in manufacturing this? Then what is the process involved in the next component level or the subcomponent level? Okay, so it is process wise in that pre-FMEA, that is this process wise in plant and this is the process involved, this is the process involved. So each of the steps, it talks about the process. In design FMEA, it talks about the design. So this is in short how it looks.
Due to shortage of time, these are the only questions we'll be taking today.
Any other questions you can write to me, you can ask me or you have a mail ID or you can, I'll give you one format.
Sir has shared his contact details as well. You can write all the other questions.
Yeah, you can you can WhatsApp to me or you fill up in this form. I'll send you the form. You tell me what type of training you want and something. I think QCI will.
So these things we are covering in a feedback form. So these things will be covered in a feedback form.
QCI will also be on feedback form. Similarly, if you can fill up this also, I know what.
This. If at all some questions are coming, either you can write it to QCI, we may forward it to Guru sir, or you may directly send your questions to Guru sir.
Yeah, you can WhatsApp to me or write it to me so that I can consolidate and answer, or you can call me up anytime.
As mentioned earlier, we will be sending the link of this webinar to all the participants. So with this, I think I should conclude the session.
Yeah, so I think you got some information because afternoon I have another webinar starting from 1 o'clock.
Sir, we request you to switch on your camera. Guru sir?
Yeah, you switched on. Am
We
I
are
visible?
not able to see you, sir.
Am I visible?
No.
No, no, sir.
It is switched on.
I think some internet issue is there at your end, sir.
No. I can see myself.
But we are not able to see you.
Is there any restriction on number of cams it can show or?
No, no, no. Others are.
Ashish, is sir visible to you? Is he?
Now?
I can see him. I can see him.
Okay.
Yeah,
Now I
now,
can
now.
also see him.
Yeah.
No, no, earlier also it was there.
Okay. So we'll be taking a group photograph for our record.
Yeah, group photo, we want many more people, no? Everybody should switch on.
Himali, you can make the announcement.
I hope you got some
request,
information about VDA FMEA because within 1 hour, 1.5 hours, we cannot cover VDA FMEA. It's a huge topic.
Yes, sir. We are planning to have a one-day session program for this, training program for this.
Yeah, one-day program. Hopefully, we'll be able to cover something.
Yes.
And I request the audience to enable their cameras for the group photograph, which is for our record purpose.
Yeah, people should smile. No, I don't see anybody smiling.
We are smiling, sir.
Group photograph, you're supposed to smile. Right? I don't know why they're serious. Is it that because they didn't understand anything?
It's not like that, sir.
Maybe that is one reason. They may be wondering what is it that was covered in 1 hour. Won't
This
understand.
was an awareness program, sir.
I think their expectation was very high.
Has been taken now. You can go ahead.
Okay, as the group photograph has been taken, I would like to take this opportunity to thank you, sir, first of all, for such an enriching session. And thank you all the participants for their active participants. And we will be sending a feedback form as mentioned earlier to all the participants. You are requested to provide us your feedback as it plays an important role in our constant development. Once again, I would like to thank Mr. Sridhar Guru for making this webinar a success, and thank you all the participants as well. I would also like to thank the QCI NBQP team for organizing this webinar. And thank you very much, everyone, and have a lovely day ahead.
Okay, thank you. You
Thank
can
you,
even fill up the other feedback
great
also. If you want to fill up and give me some information inputs, you can always fill up my feedback form on the link so that I will know what to prepare for the next session.
So,
Okay.
Thank you, sir.
That's it from my side. Thank you all. Have a good day.